Here is a little help solving the Ohm's law problems. So if you're not in class live, you can watch this video. If you have questions, pop on during the Google Meet and ask them. I'll be available for you. Or come during Del C1. Okay, you got your quote of the day, you got your directions, make sure you show all your work. So the first one, we have Zach using a speaker that's driven by an amplifier where we could change the voltage. The problem is if we make the voltage too high, it'll produce too much current through the speaker and a fuse will blow. So we want to know what is the highest voltage that we can use without blowing the fuse. So the fuse is a 1.5 amp fuse. So what we want to do is we want to look at the resistance of the speaker. We want to use Ohm's law. Use the 1.5 as your current. Use the resistance of the speaker as your R. Find the voltage. What is the maximum voltage? That will be our answer. It then wants to know what's the power and how much energy will we use during a 3-hour concert. So you shouldn't have any problem working through the rest of this. Put your work nice and neat on this slide. This time we have a resistor being used to generate heat. So we're going to run electricity through the heater. It's going to get a little bit hot. It says it generates this much heat per hour when hooked up to a car battery. It wants to know what are the colors of the 3 stripes on the resistor and how much charge comes out during that hour. So you want to start with the fact that you know energy and time. Get your power. From power, you should be able to get your current. It says it's hooked to a car battery, so you know the voltage of the car battery. You can look that up in your notes. It was in the chart when we went through the different voltages. Solve it for I. Then use Ohm's law. Again, car battery for the voltage. Take your current, put it in here, solve for resistance, and then figure out what color stripes would give you that much resistance. Just get close. So if your resistance is not perfect to one of the colors, remember there's built-in error to those resistors. So get the resistor that's closest to the resistance that you calculated. They then want to know how much charge comes out of the battery. So again, you're solving for Q. Use your current that you found here and solve for Q. The final one, you'll all get your own individual problem. We're going to use a wire this time, and the wire will generate heat, like the wire inside of your toaster, the wire inside of your hair dryer. And we want to know how much resistance the wire has and how much current we're going to get. So the resistance, we do it just like we did before. Material, I gave you the little chart down here with your materials. The length, to the best of your ability, measure your length of your wire. Get the radius of your wire. Remember, each tiny block is worth 0.1 millimeters. You're going to have to turn it into meters and then find the area using pi r squared. Once you have the resistance, finding the current should be rather easy. You just do voltage divided by resistance. The voltage should be written as part of your question. I think you should be able to handle all these, but if not, pop in during class or pop in during Macaulay 1 and ask about them.